We talk about the internet like it's magic. We call it the cloud, a weightless, invisible realm where artificial intelligence just exists. But nothing comes from nothing. The digital world is anchored by heavy, brutalist concrete and millions of miles of copper wire. Every time you ask a generative AI model to write an email or render an image, you initiate a physical reaction. You pull immense electrical power into hardware like this, and in the process, generate intense, concentrated heat. This chart shows exactly where that power draw is heading. We're looking at the average server rack power density, which hovered around 36 kilowatts in 2023. By 2027, driven by modern AI workloads, that number is projected to spike to 50 kilowatts per rack. This staggering physical energy footprint is the silent threat. If we do not change how we build these facilities, unchecked AI growth will overwhelm regional power grids and derail global climate neutrality targets. For years, the industry measured success using a metric called power usage effectiveness, or PUE. The goal was simple: push the facility's power consumption as low as technically possible. To hit those low numbers, engineers relied heavily on evaporative cooling systems. Essentially, they used massive amounts of water to absorb the heat and vent it out into the atmosphere. But as this diagram illustrates, that creates an inverse mathematical relationship. To lower power consumption on one side, you must dramatically increase water usage on the other, trading energy efficiency for millions of gallons of water. It's a zero-sum game. You've simply swapped a regional power crisis for an acute water shortage. That model functions in places where fresh water is virtually limitless. But for the fastest-growing digital markets on the planet, it is a fatal design flaw. Take the African continent. The data center landscape here is expanding rapidly, projected to reach a nearly $6.8 billion valuation by 2030. Nairobi is the ultimate crucible for this expansion. It's a thriving tech hub, but it operates under severe constraints. Persistent grid instability paired with acute regional water scarcity. This is where the traditional water-intensive cooling model breaks down. You cannot optimize for power by draining the local reservoir. Evaporating millions of gallons of municipal water in a drought-prone region strains the ecosystem and strips the facility of its social license to operate, the community's trust in its existence. Relying on fresh water to keep the internet cold when your neighbors face food and water insecurity is an operational dead end. To survive in these environments, engineering has to break out of the zero-sum trap. We have to stop venting waste and start capturing a resource. In the AI era, the industry is pivoting toward energy reuse effectiveness, or ERE. This metric tracks the percentage of total energy that is successfully repurposed for beneficial use after it leaves the servers. This shows the mechanical shift inside the server rack. Advanced liquid cooling loops capture thermal energy directly at the GPU source. The system maximizes the exhaust temperature leaving the building, ensuring high-grade thermal energy is captured in a transportable form. This process stops treating heat as a toxic waste product. It is reclassified as a highly valuable raw material. That captured high-temperature energy is then routed directly out of the server farm and into adjacent community infrastructure. In water-stressed regions like Nairobi, that heat is pumped into controlled environment agriculture. It provides the exact climate control needed to maintain precision indoor farming. The impact is quantifiable. By conservative estimates, the waste heat from just one data center can sustain vertical farms capable of feeding dozens of adults their entire daily caloric needs. This local engineering triumph is gaining traction in global markets. Institutional investors are now actively funding these circular designs through green bonds and sustainability-linked loans. Achieving verifiable resource circularity, physically and contractually, grants operators access to cheaper capital and significantly lower operational risks. True infrastructure leadership in the AI age means transforming a unidirectional power drain into a community asset. It's where the byproduct of processing data literally helps grow the food that feeds the city.